In this video, we're going to factor the greatest common factor of a polynomial. It says find the greatest common factor, GCF, of 90z to the 7th and 48z to the 5th. And then they say your answer should take the form of az to the n. So I'm going to write these two expressions out here. And what I want to do is I want to start to factor a number out of each term that's the exact same. So for me, I can see that both of these are divisible by 3. So I'm going to take out a 3, and I'm going to write this as times 30, right? 3 times 30 is still 90, z to the 7th. I'm going to do the same thing here, so that's 3 times 16, z to the 5th. And then I'm going to look at the factors of 30. Well, I have, this is an even number, and this is an even number, so I can bring out a 2 here, so I'd write 3 times 2 times 15, z to the 7th, right? That's still 90. And then 3 times 2 times 8, z to the 5th. Now you notice that this is an odd number, and the factors for 15 are 3 and 5, and this is an even number, and the factors for 8 are 4 and 2, so there's nothing else that I can pull out of the 8 and the 15. So 6 is what they have in common for a factor, and then z to the 5th is what they have in common because z to the 7th has a z to the 5th in it. So we can say that the greatest common factors for the GCF would be 6z to the 5th, because that's what they have in common between them. Let's do another one. So this time they want us to write this in factored form. It says factor the GCF out of the following expression and write your answer in factored form. So we're going to do the exact same thing we just did in the previous problem. I notice that 45, 33, and 78 all have a 3 written inside. They all have 3 as a factor for that number. So I'm going to write this as 3 times 11, x to the 3rd, y to the 3rd, plus 3 times, 3 times 26, x squared, y to the 4th. Now you notice that 11 is a prime number, so you cannot factor anything else out of this number here, which means we can't factor anything else out of the other two numbers either. So what they have in common is that they have this 3, so I'm going to write the 3 out front, so I'm basically dividing that out, I'm factoring it out. And then they have x to the 2nd in common, because that's the smallest set of x values, right? This has x to the 2nd in it, this also has x to the 2nd, so I can write 3x to the 2nd. And then y to the 3rd is the smallest, and so we can take y to the 3rd out of each of those. And then we need to write what would be left when we divide that out, because we're dividing it out and writing it out front as a multiplication. So that would leave 15. If I take 2 x's from the 5, that'd be x to the 3rd. If I take 3 y's from the 7, that'd be y to the 4th. Plus, factor the 3 out, so I just have 11 left. I take 2 of the x's, leaving 1 x left, 2 of the 3. And then I take 3 y's. Well, there were 3 y's there, so they're gone. And then I'm going to leave the 26. Take out x squared. Well, I'm canceling that out completely there. And I take 3 y's from the 4, so I just have a y left. And that's how you write the greatest common factor in factor form, where you factor it out and it's still being multiplied, right? We still have the same expression we started with, but it's in factored form.